Electricity. So today we are going to discuss three of the key components of electricity: current, voltage, and resistance. So first up, current. Current is represented by the letter I and is a flow of charge. So it's what we see when electricity flows through wires. And in wires, because they are metal, the charge is carried by the electrons and so the metals are very good conductors because they have these mobile electrons that are able to carry the charge and allow the flow of current. Things like plastics that have no free moving electrons are poor conductors, and so these are often known as insulators because they will not conduct and allow the flow of charge. The energy comes from either a cell or a battery, which is connected to our circuit. It's in a complete circuit, which then allows the flow. It provides the energy to the charge, and the current will flow along the wires, going to different components, and eventually back around to the cell again. It is measured in amps. Also called ampere. But most times we just refer to it as amps. How we measure current in an electric circuit is we use an ammeter, which is put in series, allowing the current to flow through and measuring it. Now, an ammeter is represented by this symbol, an A in a circle. So charge is closely related to the idea of current, and charge is represented by the letter Q. The unit for charge is coulombs. And we can actually use current and charge and time in a formula where charge is equal to current times time. So Q is equal to IT. So if we know the time our current is running for and the current, we can determine the charge. We know the charge and the current, we can work out how long our circuit's been running. It's a very useful equation. So next up, voltage. This is the amount of energy given to the charge. And it's measured in volts. Which is represented by the letter V. And also voltage is represented by the letter V. So we commonly look at voltage when we see how much volts are being consumed by a component in the circuit. So we can also describe voltage as potential difference. And to measure voltage, we use a voltmeter. And this is put in parallel with whatever component we want to measure the voltage of. The voltmeter is represented by a circle with a V in it. So say we have a circuit that has a light bulb present, and we want to measure how much volts were consumed by that light bulb. We would add our voltmeter like this. So it will measure the voltage before the light bulb and after. Oh dear. Here we go. After the light bulb. And so it will then display the difference. And this difference will be the voltage consumed by our lovely glowing light bulb. And so you can do that for any component within a circuit. Very, very useful. And then finally, resistance. And it's just like it sounds. It's how the wires or components resist against the flow of charge. Represented by the letter R. So energy is required to pass through any given component. And that will be its resistance. Wires have a very low resistance. So they do not affect the overall flow of current or the energy consumed. Whereas something like a light bulb has a much higher resistance. So it will affect the amount of current and voltage within the circuit. And resistance is measured using both voltage and current. Its unit is called ohms, represented by the omega symbol. And our lovely formula for it is resistance is equal to voltage over current, or R is equal to V over I. So the more resistance there is, the less current within your given circuit. Which is very, very important and will be used to discuss the ideas of parallel circuits and the path of least resistance. But that will be in our next lesson.